Hello, this is a lecture 2, Introduction to Statistics. The last time in the first lecture we just went over course overview and all the stuff, and this for this week we are diving into the main topics. So we start from statistics, then we're gonna switch back to probability, and eventually we will revisit statistics part again. So for the introduction, for this page, I have a Mentimeter link that you can click and go to the link and share what you think, what comes to your mind first when you think about the word statistics. Is it something you think is common or not? Have you used it before? Is it something you have studied before, or do you think it's important in your life in any aspect? And then I'm gonna just go to the next part, which is I think you actually when you think of statistics, or if you have studied or have seen it before, you will see lots of formulas. Again, because it's kind of math, right? You have numbers, you put numbers into the formula and give an answer and get some points, get some good grades. But and what the application? The application for this statistics is to be able to look at this kind of image or this kind of data and see what is going on here. And so nowadays you don't actually need to deal with numbers at all because there are lots of tools. You have phones, you have Excels, you have this kind of tool. For this example, this is the Facebook analytics. If you have Facebook page, or you usually even think like back when several years ago, like you're gonna need to have a business, serious business, right? And you have to collect data like income, expense, number of customers, other stuff yourself, and you need to know statistics to use them. But nowadays you just need to have a page, a Facebook page or a YouTube channel, or even TikTok. Right, and then they're gonna provide you with this kind of information, so that you can make some adjustment or some decision on what you should do with your channel, or what you should do with your page. Can you improve? What is the best time to post, for instance? And so they provide you all this information. And this is what we call the statistical information. The number of users, revenue, that's a lot. Of course, it's not my page. I Google it somewhere. My sessions, page views, and some graph. That's nice graph. The top one is numbers. Then we have some nice graph. We have some nice table, and then we have some pie chart. As you can see, this page contains lots of information, and it's your job to look at it and be able to say something about it. Say something about what you see. What are those things? What do they mean? And how you should use this information to your advantage. Okay, so and we kind of have some definition, but again, it's informal. Okay, so statistics is science. Like, it's not just you go around the street and ask people something. It is science. Like, we use those information, we use those data to give you some meaningful information. So this is a science. It's a science that deals with the collection. And this is the part that maybe the first thing you think of when you think of the word statistics. And then we analyze. You just put those information inside some app or some tools, and then interpret it. What does it say about the data itself? And presentation. But there are kind of like 4 sub-tasks that you need to do whenever you collect something and do some statistics. And then we see and use data in our everyday lives. But you know, maybe it's not like every day, like every single day or that sort of thing. But at least like you might want to collect data about when you wake up, like what time what time you wake up, or how long do you sleep each night, for instance. And you can see whether you have good health, whether you are tired, whether you need to rest more. And the goal of statistics the goals of statistics are to organize data, which is what we just saw above. Like get everything into the nice graphs, nice graph, nice charts, and then summarize them. Maybe you don't need to know every single point of data. If you ask 1,000 people, you don't need to see the table of all those 1,000 data points or 1,000 rows in Excel. Like maybe you only need to know you only need to see 5 important part on summarize them into some nice format and only see like a single page once. And then that's a main goal, which is to draw some meaningful conclusion from good data. Notice the word good with the quotation mark. Right? We don't you don't go around and see random numbers and draw some meaningful conclusion. Because the thing is, you can draw some conclusion when you take a look at lottery price, winning lottery number. And you can say, oh, okay, so last time it was 12. Like 12 was for instance, 12 was the winning number, and it's 23, and then it's 35. And you might say, oh, that looks like some curve pattern. 1, 2, 3 next should be 5, 2, 3, 5 next should be 8. You can speculate all you want, but you have to first know that this is not a good data. Like the numbers, the winning numbers collected throughout the years are not winning data because they say nothing about what is going to happen next. Because they are random. Right, so we have to make sure that the data we have at hand is good enough. They have some pattern, they have some requirement before say something about it. And of course we need to know that they are good so that we can use the right to apply to that set of data. And next we have some keywords. That's just pretty short. So for statistics there are 2 main branches, which are called descriptive and inferential. Oh, maybe I should start from here yet. So this is some nice chart from Russell.com. And so on the left we have descriptive statistics. So they just describe the data. The data is described in some kind of nice format. As you can see, there are just some numbers: 30%, 70%, 20%, 10%. They are split into kind of as a section, a donut section around the circumference of this circle, and you give them some colors: yellow, blue, red, green, pink, and surely what is missing from this maybe something like a legend that says, okay, this pink section that says 7% means the data in 2020. Green part, which says 10% is the data from 2020, and so on. And so what you do here is just put everything you have into some nice format, some nice graph, some nice chart, and you can see some, and hopefully you can see something like something pops out at first glance. Like here you can see, oh, that's pretty huge. This section, I wonder what this section represents. Look into details more on what this represents. Like here, 10% seems very small, You might want to take a look at that. Oh, it's 2020. What happened in 2020? Maybe some kind of pandemic, for instance. Then, like after you see this overview, then you can go to a specific point of data and then study more. Like for example, in this case, you don't have to look at this 3 part because they look the same. They seem like the average, and so there shouldn't be anything surprising or anything important to look into. Whereas when you move to the next part, is the Inversion Statistics. Here we study a sample of the same data. It's always still the same numbers there. It's 30, 20, 20, 20, 10. And then we use some math. Lots of math actually. Like to represent them into this kind of graph. And so these numbers are, just numbers. It doesn't say anything much. But if you know some math, you can say that, oh, actually 30 is pretty, let's say it's pretty irregular. There's something special going on that year. Right? And then if you use math, or in this case, if you use statistics, you can say even more. Like, okay, 30% growth has like maybe only 5% chance. It's kind of what you say the rare event. Oh, let's make it 1%. Let's make it pretty rare. You can say, oh, there's only 1% chance for this to happens on random equation. Then once you see this number, you can make a conclusion that, oh, there must be something special going on. It's not something you can get at random. It must be something working behind to make this number this high. And so you need some math to make this graph like this graph. And you say, oh, 30. Oh, let's make it this way. Maybe it's this graph. This graph. This one. And you say, oh, 30 is like on the right of the graph. And this part is kind of like small region. And small means the event. Like it's rare. And once you say it's rare, right, once you determine that it's a rare event, then you can investigate further on how that happened. What is the main factor that give your company this high yearly growth? So that's 2 parts. Just summarize the data using Excel or any simple tools, and use this data to analyze it furthermore with math and see other numbers behind them. And so in words, if you prefer words, I will come back here and say that, okay, the descriptive statistics, which is on the left part, and we only show or summarize the data in a meaningful way or in a nice format. Sometimes you want to make them look nice so that you can see some trends or see some pattern at glance. You can present them into some chart, like a bar chart, pie chart, histogram, polygon, and diagram. We will go over this here in the first part of the class, right? And then after you can make them into some nice presentation, like PowerPoint, and you can also summarize them using some quantity. Right? Find some numbers that those sets of data represent. And you can find distribution, which is a fancy word of drawing everything, putting everything into the same graph. See how they distribute, how many people have, how many people are in this age range, in that age range, and put them all in a nice chart. You can find the mean, which is the average. I'm pretty sure you may be familiar with it. that. There are also some other fancy keywords, but they are important because they give you some idea of what this set of data looks like. So there's a median and mode. That's like triple M. That they are the same in the same set of data, which is called the center. Then we have some dispersion, fancy word for location, and then standard deviation, and so on. So here you might need to know some formula, some statistic formula, or you need to know what to when you use to get those numbers out. And whereas for the inferential statistics, you need to be able to the goal of this branch of the inferential statistics is to draw the right conclusions from the statistical analysis from above that has been performed using descriptive statistics. For instance, you may say that okay, the mean from the first part, after we put everything into the app or the Excel, it says okay, the average is, let's say, 15. The standard deviation is 5. Then here in the second part, in the inferential statistics, we want to use those numbers to say something about the data. Is it regular, or not, or is it rare? Is it gonna give you some graph that looks pretty high, where everything is condensed into a short interval, or is it something that gonna be pretty wide? Everything is spread out across the possible values. That's the second branch, and we're gonna visit this part from week, I'm not sure, week 9, I think. So that's the second part. That's a long way from here. But for now, for this slide, we are gonna focus on the first part, which is descriptive statistics. Let's go. Yeah, shall we? Descriptive. So there are many ways you can describe, or you can show or summarize data. The most basic one is what we call the frequency tables. This is pretty much what you do when you have, if you only have paper and pencil, you go around and ask people, okay, like for example, where do you live? You live in Bangkok, Phuket, Nantaburi, Samut and so on. But that's just a piece of paper. You may have a list of province on the left, and then on the right you can simply tick this person lives in Bangkok, so I tick one line, one tick in the Bangkok row. This person lives in Notably. Okay, so it's there. And then you keep ticking, you keep asking, you keep thinking, until you finish. And then you turn that sheet of paper or that data into a table. Then those ticks into numbers. Maybe 5, 6, 7, 2, and so on. So that's the most basic one. Oh, and by the way, if you happen to have the copy of this lecture, you can click on that link. It brings you to the source for this table. Oh, and yeah, and by the way, that's the as you can see from the word quarantine, you may be able to guess that this is related to COVID. Well, that's the most basic one. Just a table that counts how frequent each row happens. Then we have some graphs. Here's some nice graph. And that's a nice graph again. This from our world in data. So let's see if I can open that thing real quick. Okay, there it is. So what we have here is United States coronavirus pandemic country profile. I agree. Yeah, so if you go to that website, they have the countries to show in all charts. It's a US, but they also collect all sorts of information from across the globe. Yeah, so we pick Thailand, and then what's that on top? Yeah, that's a chart from Thailand. So as of the day of recording is 19th August. It's here, and you can see we are. It's getting a little bit poetic because they changed the way they collect and report data, so that's why the numbers seem to drop from the peak at the peak in April, around April 1st, 26,000. But anyway, so that's a graph. And so what they do is they use they use the tables that we saw before, and then plot them into the axis, where we have one axis on the horizontal line that represents the date or the row, and then the vertical axis, like these numbers 0, 5,000, 10,000, and so on. It is the number in each entry of that table. It could be, oh yeah, that's the table, of course. So if you go to the table, yeah, that's the table. We have to see Thailand somewhere. Yeah, there. March 1st. Oh, we got that's the country we select. And then we have 2,000 plus 2,000 plus 2,000 percent. 2,000 percent mean, oh no, it's 200,000%. That's like 2,000 times higher than the point in March. Seems bad, but there's nothing much we can do about it. And so they turn this kind of table, which is kind of difficult to look at, like 2,900, 21,000, into a chart where you can see the trend from one row to another. Okay, at this point, let's say February 24th, the number of cases are 470.29. 0.29 means average, I guess. Yeah, but you can see it increase. At this point, this first peak was at August 16. Oh, that was a year ago. Yeah, 21,000 cases of COVID. And then the drop because of lockdown, I guess. It bounced back when this is when the country starts accepting tourists and loosen some policies. But yeah, that's how the graph works. And you look at the x-axis, you look at the y-axis, and see how they are related. You can see the trend, whether it is going up or it's descending down. That's graph. We are not going to teach you how to draw a graph, but at least like the basic skill is to read a graph. Pick a point here. You need to be able to find what that point represents on the x-axis and what date it is, and then on the y-axis, which is the number of cases. Oh yeah, and by the way, this is what I got this graph on in August 2 years ago, and you can see that the peak was pretty low, 250, whereas the peak we saw here is 25,000 on a scale of 100. It's sort of crazy, I suppose. And then we have a pie chart, and if you take a look at it for a moment, you can see that this is joke. So we have little pies. We have blueberry pie, apple pies, and raspberry pies. But anyway, pie chart. Again, they're just they're the same set of data, the same set of numbers, but we represent them as a section of a circle, where a whole pie or a whole circle represents the whole set of data or 100%, and then you split them into parts depending on what how large each part is. And for instance, if you go back to, let's say here, the number of essays in each country, in each province, and there are like 10. Here we have 10 provinces, so we can represent them into a chart. And we have to sum up all these numbers and say, okay, this 1,536 takes about, and let's show, I'm just gonna make some numbers up, 80%. And of all these numbers, is these Bangkok cases is worth 80%. And so you divide them by 80% of the chart here and label that Bangkok. And here you can see that, okay, instead of looking at numbers, you can see, oh, that Bangkok pie is pretty large compared to the rest of the country of Thailand. And then you see, oh, we can fill in the rest, and Phuket is here. Okay. Next, Nonthaburi, and so on. Right, so you represent them as percentage. How large is that part compared to the rest? And that's why they are called pie, because they look like pie. I don't know. Maybe if it's in Italy, they might call it pizza chart. That's the word we use nowadays. I guess it's American or British. But anyway, that's a way to represent the same set of data. A nice circle. And one thing to note here is, in this case, you don't care about the exact number. Like you don't see whether the number is like 1,587. That might be important when you look into details or get some other numbers. But for now, at a glance, if you want to convince someone that, oh, lots of people prefer Raspberry Pi, for instance, this chart is good enough for that purpose. And we have a bar chart. I think this is more common than the pie chart. Oh, but by the way, the pie chart is kind of like bad. And there's kind of rule of thumb that if you can avoid it, please avoid it at all costs. Because it's kind of misleading somehow. Or like, oh yeah, now that I'm at it. And for instance, if you have a bar chart, and then this blue section is up here, and then we have this green section down there, and then you're gonna have to spend some time and take a look at that and ask yourself whether this green part is larger than the blue part, or the blue part is larger than the green part, or are they the same? The angle can be misleading sometimes. But like in this case, if you don't have that many data groups, and if this simple enough to look, then go ahead and use it sometimes. But the more popular, the more important one is a bar chart, where you represent it into the bar. Like this is similar to the graph. The difference is that the chart, the x-axis here, this one doesn't have to be, my head is the way. It doesn't have to be numbers. You can have a bar chart where you have penguin, Peter, Panda, all those things, and compare them all in the same chart. They don't have to be numbers, so need to be arranged in the ascending order with the trend. Sometimes all you need to see is to compare the two differences together. So that's one feature about the bar chart. And another is you can do what we are seeing here. And you can compare two different sets of data next to each other. In this case, and this graph is comparing the population of dolphins and whales. To see, what's the trend? Are there more dolphins, more whales? Are they increasing, decreasing? Are they becoming, food? So, there's. And here you can see the trend that, in 2017, there are twice as much dolphin as. But next year, the number of dolphins drop in half. That's easy to see at glance. It's dropped in half. Something must have happened that year. But for whale, nothing much. But it also dropped, but not as much as the dolphin. And then we see them drop again in half. But somehow the number of whales increased next year. Again, there must be some factors behind that growth, and so on and so forth. And so you can see the trends. And if you need the exact number, then you can take a look at the left. See, what's the height. And most of the time, you don't actually need those numbers. Like you can just compare the size or the length of each bar. But for the, let's say, completeness, I guess, it gives you an idea that we are not cheating, we are not giving you some false information. These are the numbers. And because that's one way that statistics can lie to you. Just to lie about the legend or the height of the chart. In this example, this is a good chart because it starts at 0 and it increases in the same by the same amount for each step and for each line. But sometimes you can see some false or some misleading or fake news statistics. Like for instance, you might want to make people feel that this yellow chart is a lot more than the blue chart. It's a lot higher than the blue chart. And you might take a look at this one. This purple chart is 3 times higher than the blue chart. But sometimes they let's say start at 1,000, then increase in the increment of 10, so 1,020, 1,030. And then when you look at the actual number, 1,030 and 1,000, you can say that they're actually roughly the same. The difference is only 3%, only 30 out of 1,000. So I would say that they are close together. But the graph lies to us. Right? The correct one. And the correct graph would be to just draw them in the same scale, starting from 0. So here we divide the graph of 2. And here the correct chart would be like that. That's bad. I'm gonna be sad if you attempt that. But the correct one that gives you the correct representation or the correct impression of the comparison between these two sets of data is this one. And here, they are close. There's not much different. So be careful, both when you make the chart yourself or when you read some data outside. Like first start questioning whether they are in the correct scale or not. So that's a bar chart. And oh, that's a joke. I like it about. If you have there, you can click on the link. I think this from I Met Your Mother, I think, from the popular series. Okay, so we had this person represents data. For the top one, he has his favorite bars in a pie chart, and then he represents his favorite pies in the bar chart. So he's trying to confuse you. Okay, you can make the pies in pie charts and then bars in bar charts, but there's a nice joke about the use of word. Oh, and by the way, yeah, the pie. This pie means pies as food, but bars here is a bar in the word bar here means a place where you go to drink and spend the night with your friends. And yeah, you can click on the link if you have this slide and see a short clip. And I think I shouldn't put it YouTube, so that's just a nice image for you. And there's another one which is called a histogram. This again at glance it looks like a bar chart, but the difference is that in histogram you can group the numbers into branches. Right, usually even in the bar chart you have different numbers, and each number is represented as a single bar. But sometimes you have too many numbers to to put in a graph. Like for instance, in this COVID death rate by age, if you put each age as a single bar, you're gonna have like 80 bars. 80 is a lot to look at. And so what we do? What we usually do is to group them into ranges. Like here we group them into a range of 10. From 10 to 19, 20 to 29, 30 to 39, and so on. So that we only have 8 bars to look at, and we can still see the trends. Because in this case, like for people of different ages, if you are you have probably the same age, the statistics or the health issue shouldn't be differ much. If you are young, for instance, as you can see here, you have pretty low chance to die of COVID, 0.2% chance. Whereas if you are 80 or more, the chance increase by a lot. And again, you have to go to the left and see whether the graph or the height is appropriate. In this case, it is because it starts at 0 and it increases by the same amount at each step. That's a histogram. Like just group them and say something about the group instead of individual. And oh yeah, lastly, we have a nice example of descriptive statistics. I think this was similar to what we saw first about the Facebook analysis tool. So we have lots of numbers, lots of data, and they represent nicely into this chart, where the most important numbers, which is the number of people who got tested. I think back then in 2020 they didn't have ATK yet, I think. And so you have to go to hospital and test yourself. They say, 4 million people got tested. And that seems impressive, right? That means they have pretty nice healthcare. The health faculties are available everywhere, so it is easy for people to just walk or just take a drive to the testing faculty or hospital. And then you have positive rate. It is in red to to give you an impression that this number is dangerous. You don't need to see this number you don't want to see this number when it's high. I mean, 588,000 is high, but the next thing here is when compared to the negative rate, it's still pretty low. And here they represent them both in numbers up there and in pie chart down here. And it's not actually the pie, it's like half a pie. But sometimes you can adjust. If you have a pie, then you're gonna have some like maybe ugly looking circle. But then you choose to just have the pie instead. And that give you some idea of the ratio, the percentage of people who are positive and negative compared to each other. And then we have another set of data. They are the same, except I think this one is for the whole state Florida. Sorry, this is for the Florida residents. It's for all the people who live or who stay. And then we have a bar chart here. I do see the trend that the number of this percentage is decreasing, which is a nice indication that it's recovering. Then we have I think this one is a bar chart. It's pretty small. You have to go to the link and see yourself what it says. The data from last 6 days, the previous 6 days. And so this would be yesterday, and then 2 days ago, 3 days ago, 4 days ago, and so on. That's one night website people make. And by the way, the good news is this website is nice and it gives you some give you the accurate the set of data to look at. The bad news is this was not made by the government. People just volunteer and do them yourself, because sometimes governments are low. And lastly, let's end with a joke. That's one of my favorite. Well, this is from a website called XKCD. And again, you can click on the link. This comics, I guess, is called self-description. So what we have here is we have a pie chart, we have a bar chart, and we have some kind of a graph. And this bar chart on the left say, like, okay, this white fraction is the fraction of the image is white. So it's describing itself. I say, okay, this big part is white, which is, I mean, it's white because you paint it white. And then here, this one is black. Like the amount of black ink in this image is this much. Because that is this area. This is how we paint them. So that's accurate, but again, that doesn't say anything. And then we have amount of black ink by panel. Like the first panel, it doesn't have ink. So it's in the third panel. But in the second panel, in the middle one, they use lots of inks. And the reason why they use lots of inks is because they use lots of inks in this bar. You can see that they can just they can just use a thin bar chart, like a thin stick. But they don't want to. For some reason. And they make it thick instead. And since it's thick, then the amount of ink will be increased because they want it to be. And lastly, they have the location of black ink in this image, which is, they just embed the image into the graph. Like, this is the location of that ink. This is the location of that ink. So again, it doesn't say anything. It says something about themselves, but not nice or useful information by any means. And so that's the end of descriptive statistics. In the next part, we're going to learn how to look at these numbers and extract some other meaningful information.